So I found this on Facebook. How I see math word problems. If you have 4 pencils and I have 7 apples, how many pancakes will fit on the roof? Purple, because aliens don't wear hats. Can any of you relate to that? Some of the problems that you've seen in your academic careers have been like that. They're just like, what the heck? Just all these unrelated things. There will be word problems in this class. Word problems are math applied to real life. And you can learn how to do word problems. They may not ever be fun or easy for you, but you can learn how to do them. And I'm here to help you. I want you to ask me questions. If you don't feel comfortable asking in class, ask me during lab. You can text me or email me. Just pester me with questions, okay? I will match your effort. I want you to work on this. I know it's a struggle for a lot of students in Chem 3A doing these word problems. So ask me questions as we go along and don't get lost. So getting to an equation from the problem statement is the issue. Taking the words and making it into the mathematical equation, that's where people have trouble. Once you get the equation written down, most of you can solve it, no problem. It's the interpretation. One of the issues is that there's no simple formula that applies to every problem. They're all different. And so you have to learn a strategy to approach the problems. Many of the problems we see can be thought of as unit conversion problems, just converting one unit to another. But there are some that are going to require the use of specific equations. And we'll look at both of those. So converting between units. Units get multiplied, divided, canceled out, just like any algebraic quantity. So think of a variable like an x, y, a, or b in math. And, a divided by a, it cancels out, right? Well, the units work the same way. If you have meter over meter, the meters cancel out. So we can use the units as a guide to solving problems, and that technique is called dimensional analysis or unit analysis. We're looking at the units and having those tell us how to solve the problem. It's important to always write every number with its associated with unit. Always include the units in your calculations. And don't let them magically appear or disappear. I call that wishful unit canceling. Well, I wish that this would work out, so I'm just going to write it like it does. And if you've got meter times meter, those don't cancel out. That ends up being meters squared. You can't just say, well, I want it to cancel out, and so it does. You have to actually make them work out. So generally, we have a quantity with a unit, and we're asked to convert it to something with a different unit. And these are going to take this general form. They're giving you some information. You're going to apply a unit conversion factor to get the information that's asked for. So the given unit times the conversion factor. The conversion factor is the relationship between the desired unit and the given unit. And then the given units cancel out to give us the desired unit. Conversion factors are constructed from 2 quantities that are known to be equivalent. So you can find these in a table. Here's a helpful table from your book. If you need to know the relationship between kilometers and miles, there it is. 1 kilometer is 0.6214 miles. That gives the relationship between those 2 units. So those are useful. We can also make conversion factors using the SI prefixes, the metric prefixes. So on a table like this, you're not going to find the relationship between millimeters and kilometers. It's not going to be listed there because we know what milli means, we know what kilo means, and I'm going to show you how you can make your own conversion factors from those. Students often want to know, well, do I need to memorize all of these? No, you don't. There's one I want you to memorize. I want you to memorize this one. An inch is 2.54 centimeters. That is an exact relationship. We're going to use it a lot, and so I want you to know that one. The rest of them, if you needed them on an exam, I'd give them to you. I will assume that you understand some things like there's 12 inches in a foot. I think that's generally common knowledge. There's 7 days in a week, things like that, but nothing crazy like the relationship between ounces and grams or anything like that. So let's construct some conversion factors. So the relationship between feet and inches. Well, I just kind of mentioned that one. We know that 1 foot equals 12 inches. So we can make 2 different conversion factors from this information. We can say 1 foot per 12 inches, or we can write that upside down, 12 inches per 1 foot. Because 12 inches is equal to 1 foot, what does this fraction actually represent? 1. The numerator is the same as the denominator. They look different, but it's the same length, right? A foot is about this much, and 12 inches is that much. You take that, you divide it by that, you end up with 1. Anything divided by itself is 1. So this conversion factor is numerically equal to 1. When we multiply something by 1, we don't change its value. So we're changing the units, but we're not changing the actual quantity. We're just changing how it's described. So we have 2 conversion factors there between feet and inches. Inches and centimeters. 1 inch is equal to 2.54 centimeters. That's one I want you to memorize. So we can write 2 conversion factors for that as well. We could put the inch on top and 2.54 centimeters on the bottom, or we can turn it upside down. What we can't do is separate the numbers from their units. We can't say that 2.54 inches is equal to 1 centimeter, because that's not true. Just like you can't say that 1 inch is equal to 12 feet. We recognize that as being crazy. When you get into the metric stuff, people lose their minds. Any questions?